So first half, modules, microservices, really high level, architectural. I think it's time to run some code, right? So that's what we're going to do in the second half. We're going to be talking about migrating to Java modules. But well, as we all know by now, the module system is introduced in Java 9. So you'll need to move to a newer version of Java as well to do this. So quick poll, who here still develops on Java 7 or earlier? Ooh, one hand, two. Who's on Java 8? Everybody, that's what I thought. Who's using a newer version of Java already? Wow, 3 or 4. Looks like you're going to learn something new today. That's good. All right, so why the fuss? Why, when you migrate to Java 9, 10 or 11, why would it be hard? Because usually Java is really big on backwards compatibility, right? So if you have a system that you run on Java 8, just using the class path and maybe some jar file, might be a Spring Boot application or whatever, doesn't really matter, then migrating to a newer version of Java should be as easy as doing this, right? Whether that's Java 9, 10 or 11. And well, I wish it were that easy. Because yes, in a lot of cases that does hold true, but we'll see that there are lots of edge cases that have everything to do with changes in the JDK. And these changes, we've already seen them in the first part, the modularization of the JDK, that really has an effect on the applications that run on top of this modularized JDK. And this effect is even visible if your application that you're trying to migrate isn't modularized. So you can still use the class path on Java 9, 10 and 11, and you can still use everything that you knew before without having to touch modules yourself. But well, the JDK itself has been modularized and things have been encapsulated there. So that's something that you will encounter. So what we're going to be talking about today is a sort of a stepwise process to take an application from Java 8 on the class path to Java 11, first also on the class path there, and then we're going to see, can we actually try to create a module from this application? And after that, if we got that running, we actually can start to decompose this application into multiple modules. So this is a stepwise process that you might run through with your own applications as well. And I want to stress here, not every application that you're currently running on Java 8 needs to be modularized, right? Sometimes it's pretty okay to just keep running on the class path. But if you have a product that you want to maintain for a long time, that you want to structure, like we talked about in the first part, well, then it really makes sense to think about going to Java 11, which is the current long-term supported version of Java that includes the module system, and also think about what it would mean to take this from the class path to modules, where you have these explicit dependencies, the strong encapsulation, the well-defined interfaces, essentially everything that we talked about earlier. So what are we going to look at? Well, what I have for you is a typical Spring legacy application. So that means no fancy Spring Boot yet. This is a typical Spring 4 application using Hibernate, doing a little database access and some Spring services. As you can see here, we have a book service, we have a book store service. There's even some XML configuration still in there. I think that we have a lot of these applications running in the Netherlands, probably here as well. And what if you were given such an application and you had to take it into the modern age? So you had to migrate this to Java 11. So what this would look like when you run it on Java 11 is a little bit like this. So we have Spring and all its dependencies. Well, we all know there are a lot of dependencies when you do Spring development. We have our application code, which is also on the class path above the line here. But underneath, it will be running on a modular JDK. So all these Java modules that we saw in the previous presentation, they are underneath this application. Even if the application that we're going to migrate to Java 11 doesn't do anything with modules yet. And if you look closely, you see that the class path also has another name in Java 11. It's actually called the unnamed module. So even though we are, at least in the first step, not going to do anything with modules when taking this application from Java 8 to Java 11, underneath, it's actually already running as a sort of module. Namely, it's the unnamed module. And it's a really special module, as we'll see. It has special privileges and special behavior. But by moving from Java 8 to Java 11, you're already partaking in the module system, whether you knew it or not. And we'll see this unnamed module coming back in various places. So, well, what better way than to just try it? And where this says Java 10, just read Java 11, doesn't really matter. So let's say we have this application, and I have the steps in different subdirectories. So I'm going to go to the Classpath solution here. And this is really just the application that I've just shown. We have a main class which bootstraps Spring, so it creates an application context, gets some beans, calls some methods on the beans, and this will store some books in a database and get them again. And underneath these implementations, these are just Spring services. This is a repository, transactional repository, where we inject the session factory and do some manipulation. I mean, this is just something that you can encounter everywhere in the wild. So we're currently running on Java version 8, as you can see. And I've created a small run script because I didn't want to cloud the issue by using build tools. I just want to show what's really happening. So we see here that we create a class path with all these libraries that we need for a Spring application, and it's impressive what we need, but it works. And then we are going to compile the application just with a simple javac command. Then we're going to run it with the same class path and the classes that have been compiled. And as you will see, this will work as you'd expect. So Spring is starting, the application is already compiled. It's bootstrapping the context, and look at that, our application ran. It created some books, it retrieved the books, it provided them to some service that calculated in total with the tags. So this is the application that we want to migrate to Java 11. So let's just do that. And what I'm going to do this in 2 steps. So first I'm going to focus on compilation. And what I'm going to do is use a small tool to say set JDK 11. Notice that the 1 dot prefix has been dropped for Java 9, 10, and 11. So finally got rid of the useless 1 dot prefix. And now we can see that we are running Java 11. All right, that's good. So what happens if I run the same script? Well, actually, it works. So it compiled in Java 11 without any errors, without any warnings. Yay for backward compatibility. That's good. So what happens if we run the application? Well, we can find it out pretty easily. It seems to boot up. That's very helpful. There we go. And well, now our dreams are shattered because, as you can see, we got an exception. So what we see here is that there's a class not found exception. JavaX XML binds JXB. So somehow underneath JXB is used, which is XML binding technology, and it works in Java 8, but it doesn't in Java 11. What's up there? So what we're seeing here is actually one of the 3 main problems that you can run into when you migrate a class path-based application from Java 8 to Java 11. And the first one has to do with the fact that there were some enterprise modules in the JDK, of which JXB was part, but they have been removed from Java SE. And we'll see a little bit more detail about that later, but this is really the issue that we're running into now. The second issue that you can run into when migrating to Java 11 is the fact that sometimes code that we write, or that libraries write, abuse internals of the JDK. So they use types of the JDK that are not publicly supported. Up until Java 8, this was perfectly possible because there was no real strong encapsulation in the JDK. However, when you move to the Modular JDK, then things are actually encapsulated in the Java platform itself as well. And that has effects on the code that we want to run as well. The third one, we're not going to go into too deeply, or not at all even in this talk, But you might also encounter problems with split packages. And a split package occurs when you have types in a certain package, for example, javax.annotation, which occur both in a jar file on the class path and are also inside of some module in the JDK. And if you have that situation, if you have a jar file on the class path that has the same package as some other package that lives in the JDK, then your jar file, the package that's in there, will be ignored. And that's something that behaves differently in Java 8 as well. Again, you might not run into this too often, but know about the problem. The first two problems are the ones that you most probably run into when running on Java 11. So before fixing the issue that we got in our Spring application, let's try to reproduce it in a simple, small example. If we have this source file, which makes use of the data type converter class, which is part of JavaX XML bind package, and we try to compile this on Java 11, then we get a compile error and says, okay, this JavaX XML bind package doesn't even exist. And this is a manifestation of the same error that we got when running our application, our Spring application at runtime. So it has the same root cause. And the root cause is the fact that we have a difference between what was in the JDK before Java 11 and what is in the JDK after Java 11. So in Java 9 and 10, the modular JDK looked sort of like this. And there's the Java XML bind module. So this module was there in Java 9 and 10. It was also there before that, but it wasn't in the module then. And if we look at this graph closely, we can see that this Java XML bind module is only reachable when you start at the Java SE EE aggregator module. And EE stands for Enterprise Edition. And there are several more of these modules that are only reachable from the Java SE EE side of things. And Oracle and the JDK team effectively wanted to get rid of these EE modules in the Java platform. They really shouldn't have been there. I mean, it's a historical accident that we had some enterprise parts already in the Java Standard Edition, and they wanted to get rid of this. And if you want to look at what should be part of Java, then you have to look at the root that starts with Java SE. So every module that's reachable from Java SE is actually part of the Java SE specification and will be maintained. But they didn't want to remove things prematurely, so in Java 9 and 10, these modules in the Java SE EE were still available. You had to do some tricks to use them, but they were still there. In Java 11, that changed. So in Java 11, these modules have been removed, just because they shouldn't have been part of the Java SE distribution in the first place. Now, what does this mean for our applications? Because, well, like we saw, for example, Spring uses JAX-B. And there might be others as well. So here's a clearer picture of the modules that have been removed. So Corba is gone. Well, I don't know if any of you have worked with Corba, but good riddance. But also the XML WS stack, JAX-B. So lots of stuff that might have been used by lots of code. So could we have found out this in a different way other than just trying to run or compile code on Java 11? Yes. Fortunately, there's also a tool that helps us when migrating to newer versions of Java. The tool is called jdeps. And if you provide jdeps, for example, with the main class that we just saw, so the example that used the data type converter from JAX-B, then you will actually get in the output a summary of all the dependencies that have been detected in this class file. And you can also provide a jar file to jdeps. It doesn't have to be a single class file. And as you can see here, it says, okay, well, it has a dependency on Java lang from the module Java base. Well, that's something that every module has an implicit dependency on. But also there's a dependency found to the JavaX XML bind package. And well, that's not there. So here we see the same issue that the compiler found and that the runtime found previously. So how can you fix this? Well, like I said, in Java 9 and 10, it was a little bit easier because the modules were still there. They're just not there by default. So in Java 9 and 10, what you could do is use the add modules flag to force the Java compiler and the Java runtime to also resolve this Java XML bind module. However, I urge you, please don't use Java 9 and 10 anymore because, well, we've moved past that. They're unsupported now. We're now at Java 11, which, like I said, is one of the versions that will be there for a long time because Oracle has committed to long-term support for Java 11 and other parties, other vendors as well, amongst which adopt Open JDK, which is also very well known, of course, here in the London Java community. So we need a fix that works on Java 11 and later as well. Well, that's a pretty obvious fix. If it's not there in the JDK and you need it in your application, just add it as a dependency. So what we need to do now to get this Spring example running again is to add this JDEPs API and implementation as dependency. So we can do that, and I've already created a directory with these two dependencies here, and let me just quickly show the coordinates. If you encounter this issue, then these are the coordinates to look for in Maven Central. So you need a JDEPs API and you need an implementation where this is the reference implementation of JDEPs. And let's see how that works out. So the only thing that I'm going to do now is I'm going to extend my class path, and why doesn't this work? Well, let me get snippets somewhere else. There we go. All right, so I added these two jar files, and let's try and run this application again. There we go. Wait a little bit. And there we go. All right, so the application now works. It runs on Java 11 on the class path. We didn't do anything with modules yet, but we were bitten by the fact that some modules, some enterprise modules, were removed in Java 11. But there's another thing that's happening here, and that we didn't have before. There's a fairly intrusive warning here. So I'm going to show this in slides. It's more legible. So what we see here is a warning that's not produced by our code. It's not produced by any of the libraries that we use. This is actually produced by the JDK itself, which is pretty rare because usually the Java runtime doesn't spam our console. So this must be important. And it sort of is. So what it says, some illegal reflective access happened. Ooh, sounds dangerous. And apparently there's some method on class loader called define class, which is not a public class, a public method apparently, but still Java Assist, the security actions class in Java Assist, try to hack into this by means of reflection. And we all know reflection can do anything, right? Well, it used to, but things are changing. And it tried to hack into this define class method to do its work. So apparently this is not something that we should be happy with because, well, here's this warning. So what can we do about this? In general, you could say this is not really our problem, right? Because this is library code and it does something that it shouldn't do. So the first thing that you should do, is, and it also says this in the warning, is try to contact the maintainers of Java Assist and tell them, hey, you're using non-public APIs of Java, please change this, because in a future release of Java, this might break. This is what the warning says. All illegal access operations will be denied in a future release. So they need to do some work there. And luckily for us, they actually fixed this in Java Assist in a newer version. So one way to fix this would be to upgrade to a newer version of Java Assist. But if for some reason we have a library that hasn't fixed anything yet and that we still want to run without this warning, then we need to tell the JDK, okay, for this time, it's okay. Please make it possible for Java Assist to actually use this define class method even though it shouldn't. And you do this using the add opens flag. And you can provide it to the runtime where you say, okay, from the java.base module, please, everything that's in the Java lang package, which includes class loader, what we're talking about, open this up to the unnamed module, because our code is still running on the module path, on the class path, right? So if we add this, the application will still run just like before, only it won't show the warning anymore. But it might still break in a future release, where things are maybe changed or removed, because it's still an unsupported API that we're pointing to. So in the end, the best solution is to remove any code that uses non-public APIs. So if this would have occurred in our own application code, then it would be on us to change this. And to give a little example of how that might happen, I have this sample application. So let's say we have some code that still uses the Sun Security X509 name class. Who doesn't know it, right? But anyway, this is a class that you could use in Java 8 and earlier. And there are others as well. There are some base 64 decoder and encoder classes that are pretty popular in application code to use that are non-public. So if you would compile this on Java 8 and run it on Java 11, you will get a warning, like we just saw before. But if we try to compile this on Java 11, it will not allow us to do this. It will not allow us to create new legacy code using the Java 11 compiler. Because, well, you simply shouldn't do that. And again, jdeps to the rescue. We don't have to find this out by compiler error. We can also pass the jdeps JDK internals flag. And what it will tell us is it will scan our main class, and it will tell us, okay, this X500 name that you use from the Sun Security X509 package, don't do that. Instead, please use the suggested replacement, which is the one in the Java X Security of X500 package, which, by the way, has been there since Java 1.4, right? So maybe it's time to update your code. So again, jdeps can help us in identifying any issues that we might encounter with our code bases that we want to migrate to Java 11. And if this is our code, it's on us to solve this. If something like this happens in a library, we can work around it for the time being, but the real solution should be provided by a library update. So we saw that we could compile with Java 8 and run it on Java 10 or 11, and it works, but it produces a warning. In the end, what you should strive for is to be able to run your application with the illegal access flag set to deny, meaning that any illegal access that the JVM detects will be turned into an error rather than a warning. So if you can run your application with this flag, then you know for sure that your application is free of any dependencies on JDK internals, on Java internals. So that's something that you should strive for. And if you turn on this flag and you do still have code that uses internals, then you will get an illegal access error rather than a warning. In this case of the Sun Security example, what happened is that we wanted to use a class that's part of an encapsulated package. If we cannot change that or don't want to change that yet in our code, or maybe in a library, then you can use the add exports flag. And it has the same syntax as the add opens, and we'll discuss a little bit about the difference between opening a package and exporting a package later. But using this flag, you can also make this code run on Java 10, 9, or 11. So quick recap, because we just took the first step from Java 8 to Java 11. The best way to approach this is to at least upgrade your tooling, your build tooling, your IDEs, etc., everything, so they support Java 11. That's the minimum you should do. It will also be beneficial to update library versions, because in the past year, lots of libraries have addressed the issues that they had with using strongly encapsulated parts of the JDK. However, it's not always clear if you're going to update dependencies and something breaks, if it's because of the update of dependencies or because of the move to Java 11. So that's why, in this case, I just wanted to show you what happens if you leave all the dependencies alone and you want to get it running on Java 11. It is possible. Well, it will be easier with more recent versions of Spring, with more recent versions of Hibernate, etc., because they've mostly addressed all of the issues that they had with use of internal JVM JDK types. Use jdeps, so you can use the trial and error approach, just compile and run and see what happens. But jdeps gives you a much better overview of any potential problems. So you can find dependencies on these removed EE modules. You can see if there are any JDK internals. jdeps cannot actually detect split packages. There are different tools for that as well. But yeah, use these tools to approach your code base when migrating. And then just start fixing these illegal warnings, either by updating a library or by adding these flags that we talked about. Your goal is to eliminate any dependencies in the end that won't work with future versions of Java. So that was step one, right? So we had a Classpath-based application which ran on Java 8, now runs on Java 11. It's good. But we were talking about modules as well. Because, well, typically this is sort of how we think about the application, how we want the application to look, what we would write on the whiteboard. But this is the reality, right? This is the class path. And as we talked about before, here there are no explicit dependencies. Here there is no encapsulation. This is just a free-for-all. And I mean, well, we sort of succeeded in creating tools around the class path that helped us to address the most problematic parts. But still, we've seen modules offer a way forward that gives us more explicit dependencies and a better way to encapsulate. So, yes, if we move to modules, we can actually make these into real modules in our code base and have the compiler and the runtime help us there. But to get there, I'm going to skip this because we've seen what module descriptors look like. To get there, we want to migrate our application to the modular world in Java 11. And before we look at our Spring application, I first want to talk about how to handle dependencies. Because we saw that in module descriptors, if you need another module, you need to be able to refer to this other module using a require statement. That sort of requires the other thing that you refer to also be a module. So you saw that we had like 40 dependencies in our application. Should these all be modularized before we can modularize our application? That would be a bad thing, right? Because that might take ages before the libraries themselves add module descriptors. So fortunately, there's a solution. So what if, in this example, we would have a simple demonstrator in a single jar. And it has a dependency on commons lang. There's only one class in this demonstrator.jar. It's this one, it's the demo class. And it uses the commons lang dependency because, well, we've learned from the JavaScript folks that we need a dependency for left pad, right? So that's what we do. And what we want to do is we want to modularize this demonstrator application. We want to turn this demonstrator jar into a module. And well, now we just compile this on the class path, right? We put the commons lang jar on the class path, we compile our class and we run it. This is the old situation, but we want this demonstrator jar to become a module. But that's a problem, because then we would need to add a module descriptor to this demonstrator jar, and we need to somehow reference our dependency. But commons lang is not a module yet. It doesn't have a module descriptor, so it doesn't have a name that we can refer to. So how to solve this? Well, we could, of course, maybe patch commons lang and add a module descriptor ourselves. But, well, we all know it's not a very good idea to patch other people's code because you don't know the intent, you don't know really what you need to write in the module descriptor. And it's also maybe something that you could do for a single dependency, but we are not going to do that for 40 dependencies, right? So we don't want to change commons lang. We also don't want to wait for commons lang to migrate to a module. So we need something else. And that something else is a feature called automatic modules. And what automatic modules enable us to do is to take a plain non-modular jar file from the class path and put it on the module path, which is the module equivalent of the class path. And then as if by magic, it will turn into a module, a so-called automatic module. It will not be a very good module, as we'll see, but at least it will be usable as a module. So what happens is this, it will become a module that gets a name, and the name will be either derived from the jar file, which is bad, of course, because, well, that's really something that's dependent on how you name the file, or it will be derived from a automatic module name header in the manifest file, in the jar file. Again, that's something that the library maintainer should add, but that's a one-line fix. That's much, much easier than really modularizing a library. So what we see in Maven Central is that there are many more libraries that have this automatic module name header than there are libraries that have a module descriptor. Well, so we have this module, and we have this jar file that turns into a module by putting it on the module path, and it will export all of its packages because, well, yeah, the JVM cannot guess what is public API and what is internal API. So, like I said, it's not really a great module, but at least it's usable as a module. And it will have a dependency, this automatic module, on all other modules that are currently resolved, because there's no descriptor saying what the real dependencies are, so it must be able to have a dependency on everything. And this is a crucial difference between the modules that we make and automatic modules. Automatic modules can also make use of code on the class path. So what this enables us to do is to do a stepwise migration of our dependencies by picking up some of the dependencies from the class path, putting them on the module path, so we can refer to them in our module descriptor. So what would this look like in the simple example? Well, we could create a module descriptor with module demonstrator. It requires comments.lang 3, which is derived from the jar file name in this case. And we can now compile with the module path and the module source path. So we compile our code as a module, and the comments.lang jar will be treated as an automatic module. And at runtime, similarly, we have a module path rather than a class path, where we put modules, well, in this case, the demonstrator module, which is in the mods directory, and the comments.lang, which is in the lib directory. And this is how we turn this simple example from the class path to the module path, without having to wait for comments.lang to also become a module. So what we're going to do now is we're going to cheat a little bit, because, well, when we think about modular applications, we think about our application being split into multiple modules. But what we're first going to do is to sort of create a single module around the Spring application that we just saw, just to tease out all the technical issues with our dependencies. So what we'll see is that some of our dependencies will become automatic modules. We'll also leave a lot on the class path still. And what happens is that the libraries that we put on the module path will be the libraries that we have direct dependencies on from the code that's in our code base. So the types that we actively use will need to become automatic modules. And as a first step, what we need to do now is to introduce a module descriptor. And we're going to compile with the module source path, and we're going to use the module path together with the class path to get the first step of our migration going. So let's try that again. And now we're going to switch to monolithic Spring solution, which is this one. This is still the same code, so not a single line of code has changed. The only thing that has happened is that we added a module descriptor. And as you can see, it's currently empty. But, well, let's just see what happens if we run our script. And in this case, you can see that we still have a class path, but we now also have a module path and a module source path where we're compiling from. And just to show you, the class path still consists of the majority of the dependencies that we also had in the original solution. But a select few are moved to the module path so that we can refer to them as modules from our module descriptor. So let's run this. Oh. That's better. As you can see, we get lots of compile errors. For example, it says, okay, I can't read the org Spring framework context support package. That's because, well, we have this import here. And if this is inside of a module and we're using code from another module, well, we probably still remember, then we need to have explicit dependencies in our module descriptor. So we're going to add those. Okay, something is seriously broken with my snippet manager here. So I'm going to do this manually again. There we go. So now we express the dependencies that our code has, because we have code referring to types from the Spring context, that's the application context. We use the transaction annotations, we used some injection annotations, we used the Hibernate core API, some JPA annotations. This is everything that you will find back here in the source code. Now, if we try this again, we get much improved output, but we still get an error, which is really interesting. And what it says is, okay, I cannot access something that's called referenceable. And apparently, the get current session returns something that implements this javax.naming that's referenceable. This is a really obscure and strange error, right? This has everything to do with the fact that we're using a Spring version and a Hibernate version that hasn't been modularized, that hasn't been optimized for Java 11 yet. But still, we can get this to work. Because it turns out that the Hibernate core API, the Hibernate core implementation, has a dependency on this java.naming module. When we were on the class path, we could just access any module in the JDK because, well, we're on the class path, we're not in the module world, but we're now in the module world, so we need to be explicit about the dependencies that we have. That also holds for the Hibernate module. But it's not a real module, right? It's an automatic module. So it has a generated sort of module descriptor. And it can't really know about this dependency to the JavaX naming, the Java naming module. So if Hibernate itself ships with its own module descriptor, this would be expressed there. And then it wouldn't bother us, it would all work through the module resolution. But now, for the time being, we need to fix this ourselves. So what we can do is we can jump into our compile command, and we can just say, just like we saw before, we can use the add modules flag, which forces this module to be resolved. And so this way, Hibernate will be able to find the Java naming module and to use the types that are in there. And if we compile this now, we actually have a successful compilation of our application as a module. And you can see the module info is also preserved in binary format, so it can be used by the JVM to verify dependencies, module path. So this is the output that we can work with now. The question is, will it also run? So let's try that. We're going to run the application with our old class path and the new module path. And we're just going to start our main class, which bootstraps Spring. And you pretty quickly see that it errors out with a class not found exception. It says, okay, I can't find Java SQL exception. And this is a problem that's actually similar to what happens with Hibernate. So there are some dependencies, especially from the Spring transaction module, to Java SQL types. And because there's no module descriptor yet in Spring, the module system doesn't really know about this dependency. And it will not resolve this Java SQL module. Because that, by default, Java will try to keep the module graph as minimal as possible, right? So what we can do here is similar to what we did for Java naming at compile time. And I'm also going to add the add opens that we talked about for Java Assist, because even though it was only a warning on the class path, if you're in the module world, then strong encapsulation is in full effect. So if we want Java Assist to still work, we need to open up this Java lang package to do its reflection magic. So if we do this, and we run the application, then we will see that the compilation succeeds, startup succeeds, but we now run into an issue that has everything to do with the design of our module. It says that the Hibernate book service tries to instantiate reflectively some class, because, well, that's what Spring does, that's what Hibernate does. They use reflection on everything. And as we remember, strong encapsulation disallows reflection. So if a package is inside of a module, no matter how hard you try, you cannot get at it, not even using reflection. And the question is, how do we get around this? Because we don't really want to expose these implementation types, because then people can actually take a dependency on them and code against these implementation classes. And that's something that we want to prevent. But at the same time, we want to give Spring and Hibernate the ability to do their magic at runtime using reflection, because, well, we're using these libraries and they still need to function. So what you can use there is the notion of an open package. An open package is a package that contains types that you don't want developers to take a dependency on at compile time, but that you do want to expose to frameworks at runtime for reflective use. So this is exactly what we need to do in the case of Spring applications, or in the case of Hibernate applications. There we want to expose entities so they can be reflectively instantiated. We want to expose service implementation classes so that Spring can instantiate them and maybe even inject into private fields or whatever. These are all things that are made possible using open packages. So what we do for that is that we are going to, of course, let me preempt this by going here. There we go. So we want to be explicit about what is exported, so what's really API. That's in our API package in this example, service interfaces, some entity interfaces. Those are things that other modules may use, but these are only things that should be available at runtime for Spring and Hibernate to use reflectively. And we do this with opens. You can already see that there's impl in the package name, so this is really something that you shouldn't code against, but that should be usable by Spring and Hibernate at runtime. And if we do that, we have an application that compiles on Java 11 as a module, that boots, and that actually runs and has the behavior that we expect. So that's quite a journey, right? Lots of moving parts. And like I said, some of this pain is, in this case, self-inflicted, because if you're using Spring 5, for example, Spring 5.1, I believe, lots of these issues have already been fixed in Spring itself. But, I mean, this is the real world, right? This is what you can encounter when you move legacy code bases to Java 11. Now, of course, and I'm going to quickly jump over this. Of course, this shouldn't be the end situation, because everything is now inside of a single module, and, well, that sort of misses the point of modules. We want to have a modular application. That means that we want to have multiple parts. We want to split up modules that we want to assign to different teams. We want to have explicit interfaces between parts of our application. So this is something that you want to work towards. But the nice thing is that we've now enabled this, because what we can do now is we can start to think about what are the actual module boundaries that we want to enforce. And what I'm going to show you is just an example. You can choose different module boundaries, and what makes sense is really application dependent. But as you can see, I chopped up this application into 4 modules. So we have 4 module directories here under the source tree. They each have their own module descriptor. So for example, the main module, it requires Spring context because it's bootstraps Spring with application context, and it requires our Books API and our Bookstore module. So we see that here's where everything comes together. Now if we look at the Books API module, this is a module that exports some packages. And of course, in the import package, we have a dependency on this API because, well, we also need an implementation of the API. And this implementation makes use of Spring transaction notations, of Hibernate APIs, etc. And it has to open itself to Hibernate and Spring like we did before. But effectively, what I did here is just to spread out the work that we did in a single module across multiple modules in this situation. And no, let's get back here. Some choices that you get to make is, do I want a separate API module and separate implementation module, or do I combine them like I did here for the bookstore module? There we have a module that has both an exported package, but also an encapsulated package. And it really depends again on the situation. Typically you have a separate API package if you expect there to be multiple implementation modules, for example. That might be a good reason. That really depends on the design of your application. But this is really where it all comes together, where you can see that the module descriptors that each of these modules has really tell something about the module itself. And for example, we see module main itself doesn't really do anything with Hibernate, for example, whereas our book repository does have this Hibernate dependency. And hence also needs to open packages for reflective use at runtime. So, to sum it up, what did we do? We took a Classpath-based Spring legacy application. We moved it to the Classpath on Java 11. We saw that you could run into several issues there, mainly to do with encapsulated types, with remove types in the JDK. We solved those. What I did then is create a single module descriptor for the whole application. And whether you should take this approach really depends on the structure of your code base. If you already have a build, for example, that consists of multiple Maven modules or multiple Gradle modules, then this approach doesn't really make sense. Then it makes more sense to do a module descriptor per Maven module or per Gradle module. So again, there it depends on what you have already. And after we teased out the technical details that we ran into because of the somewhat older libraries, then we had the freedom to actually create module descriptors for individual parts of your application and migrate our application fully to modules. And again, I want to stress that it's not necessary to take all these 3 steps for every application that you want to move to Java 11. Sometimes you just want to move it to Java 11, stay on the Classpath, that's fine. Other times you have an application that you really want to structure more, that you want to make viable for the long term, and then it really makes sense to start thinking about module descriptors, and entering the modular world as well. So when you encounter these issues, even when moving to the Classpath in Java 11, if you still see any of these illegal access warnings, when they come from libraries, please open issues, maybe even pull requests, because this is how we move everything forward. This is how we make everything compatible with the future of Java. And in the end, you can still work around with some of the flags that we saw, but well, that's really a suboptimal solution. So, of course, one of the big questions is, well, should I do it? Should I move to Java 11? Well, I don't know. Again, I think you should. Case in point is that Oracle JDK doesn't have any free public support anymore, for example. So if you're on Oracle JDK 8, you either have the choice of moving to some OpenJDK 8 distribution, which is long-term supported, maybe from Adopt OpenJDK or Red Hat, which is a migration in and of itself as well, because Oracle JDK and OpenJDK 8 are really not equivalent. Or you could take this as an opportunity to move to something that's current and that's supported, and that would be OpenJDK 11. So really now's a great time to start these migrations, to start planning them out, to use tools like jdeps to see what you're up against. But of course, I mean, it's still possible to stay in Java 8 if you want. You can even pay Oracle, right? I know it's novel, but it's a possibility as well. But in the end, I mean, there's much more in Java that has happened since Java 8 than just the module system. I mean, we've focused on the module system. There are security improvements, performance improvements, new APIs, there's a new HTTP client, and lots of other stuff. If you're interested in that, I have a talk on YouTube called Keeping Up with Java, which details all the other new features that are in Java 9, 10, and 11. So really, there's lots and lots of good reasons to move there. And like I said, now is a great time. So again, thanks everybody. Thanks for listening to me. I hope you enjoyed it. As a little token of my appreciation, I do have some cards with a free month of Pluralsight, if you're interested in that. So please come up and take one if you want one. At this URL you can find some of my courses there. And if you have any questions left, I'll still be here until we get kicked out. So please do come up and discuss. Thanks.